Hello guys, welcome to my channel, and in this video we'll discuss article number 2.8.2 potential energy of a system of two charges in an external field. In my previous video I explained you what is the potential energy of a charge in an external field. Okay, so now next we ask what is the potential energy of a system of two charges q1 and q2 located in r1 and r2 respectively in an external field. Okay, so here what is given, external field is given. We discussed about this external field in our previous video in detail. Okay, and now there are two charges, suppose q1 and q2, and their position vectors are r1, the position vector of second charge is r2. Okay, with respect to some origin. Okay, so we have to find what's the potential energy of these two charges, this system kept in an external electric field. Okay, so we'll work on it now. First we calculate the work done bringing a charge q1 from infinity to r1. Okay, so we'll follow the same step as we discussed in the two videos earlier. What we'll do, we'll first, so this is electric field given, and first of all we'll bring the first charge q1 at any point, at some point, this point r1 whose position vector is r1. Okay, I'll name this point a, so I'll bring the q1 charge first charge from infinity to this point. So what is the work I do? Okay, so work done by me is, the external work done is charge times the potential of this point. Suppose the potential of this point, this particular point is, which is in the electric field, is v r1. So the potential is this, and what is the work done? So I'll just multiply the magnitude of the charge, first charge, with the potential, and I'll get the work that I have to do, the external work I have to do. Okay, and that will be the potential energy of this charge in this point. Okay, so now, so work done in this step is q1 r vr1. This is same as we discussed in the previous video. Okay, okay, now next we consider the work done in bringing q2 to r2. Okay, so our first charge has been brought. Okay, now we'll bring the next charge, that is q2 charge. Now you'll see that this q2 charge we have to do work against two work we have to do. Okay, against two sources, that is now I have to do work against this electric field for bringing a charge q2 that at this r2 position. Okay, and also this charge will also have a potential at this point. Okay, so I have to do work against that electric field also. Okay, so now the total work done will be, we'll see the work done now. In this step, work is done not only against the external field E, but also against the field due to Q1. Okay, this is exactly what I said. We have to do work against the external electric field as well as the electric field created by the first charge. Okay, now work done on Q2 against the external field, electric field. So this is very easy. So what is the work done by the work done in against the first electric field? Similar to the first one, this is Q2 charge of magnitude of the second charge multiply the potential at that point due to the electric field, that is vr2. Okay, this is the work done on q2 due to the against the electric field. Okay, now we also have to do work against the first charge, that is work done on q2 against the field due to q1 is what? This is, as we have seen in the previous videos, that this work is simply multiply the potential due to the first charge at that point by the magnitude of the second charge. So v1 is what? q1 by 4 pi epsilon naught r12. Okay, this is the distance between the 2 points r1 and r2. Okay, and just multiply this with the second charge magnitude and we'll get the work. So this is the work that I do, that external work I have to do against the electric field of the first charge to bring it that r2 position. Okay, so now where r12 is the distance between the q1 and q2, we have made use of equation 2.27 and 2.22. Okay, now by the superposition principle for field, we add up the work done on q2 against the two field. Okay, so we'll use the superposition principle and we'll just add the work. The total work will be what? In bringing q2 to r2 will be this will be added, this two work will be added against the external electric field against the field of the charge q1. Okay, so total work in bringing q2 to this point r2 is what? This much work we have done. And now, so for the charge q1, what work did we do? So we did this work q1 v1 vr1, and for this the work done is this much. So total potential of the system is the total work done in assembling this configuration, and that is q1 vr1 plus q2 vr2 plus q1 q2 4 pi epsilon naught r12. Okay, so this is the work we have to do in arranging a configuration in making a system of charge, two charge in an external field. Okay, we'll use this equation in the next discussion, that is in the potential energy of a dipole in an external field. So have a look at it, because we'll use this in the next lecture. Okay, if you like this video, please give it a thumbs up, and to subscribe and share my channel so that my channel can grow. Thanks for watching.